Thank you, everyone. So there's a lot of talk today about the advantages of modernizing infrastructure, technology, and processes. And although these efforts often sound enticing, the thought of actually executing on such a massive organizational change can be incredibly overwhelming. Today, I'm going to share with you how over the last year, New Relic took our older, organically developed US region and all the surrounding processes and transformed that into a modern, reliable, and repeatable system for generating regions on a global scale. Because we're all on this journey together, I want to share our story. And by doing so, I hope that we can help encourage you to implement bold and forward-looking changes inside all of your organizations. So if you've ever wondered, why should we modernize our infrastructure? Or you felt that you were simply too big to implement broad change. Or maybe you just needed some concrete ideas to convince your organization why they should modernize, and this talk is intended for you. But before we get much further, I want to take a moment to define a few core terms that I'm going to use throughout this talk. So in the context of this talk, a data center is simply a single building that houses physical servers, and a region is then a redundant group of data centers that all together provide the computing power for a software deployment target like US production or EU production or even Australia. So in early 2017, New Relic had a single region located in the Midwest United States. This region was made up of multiple data centers, but potentially it could still be negatively impacted by some broad regional event. Now, despite this fact, that single region in the US has served us well for over a decade. But in early 2017, it became apparent that New Relic had numerous business needs that were going to require the development of new regions. And although we certainly could have settled on just trying to stand up region number 2, we quickly realized that we might actually be able to design a solution that would allow us to spin up regions almost as easily as we spun up small service clusters if we simply followed many of the same design principles. So when we started to consider the business need, the use case that actually intrigued us the most was disaster recovery. Now, this wasn't because we thought there was a high likelihood that we would experience a disaster, but instead because if we approached the project from this perspective, it would help ensure that we designed the system so that everything could be built up from scratch. We could assume that there was nothing there and bring up a complete running region. In theory, this would then allow us to repeatedly spin up a new region and completely tear it down during testing cycles, which in turn would help us ensure that we were always testing that the new processes we developed could take us from nothing to a fully functioning region. As a global company, we also need to ensure that we have the flexibility to respond to regional laws and ensure that we handle our customers' data within agreed upon parameters. This is an important step to ensure that New Relic is considered a trusted steward for all of the data that you send us. And finally, because our international customer base has been growing rapidly, taking the time to bring the UI and data closer to our customers should generally improve performance and the overall experience. Probably like many of you, we were in a situation where we were simply starting to outgrow the systems that had gotten us to where we were. Yet many of the potential fast paths forward felt both complicated and risky. When the business first proposed this project to New Relic Engineering, we immediately realized that the scope of this effort could be really huge. So we actually took a step back, and we looked at the existing infrastructure, and we considered at a high level what it was we wanted to ensure that we fixed as we designed and implemented this new project. The first core concept that we landed on was repeatability. It was really important to engineering that this solution was not focused on simply building our second region, but that we were building a system that would let us build out any number of regions using the exact same process in the future. The second major feature was consistency, which is directly related to repeatability. With consistency, though, we wanted to ensure that the regions would all look the same and expose the same interfaces for other teams to rely on. This meant that a region in one cloud provider could not deviate significantly from a region that was deployed onto bare metal inside a data center. The interface and functionality that they exposed needed to be consistent. And finally, automation was critical. We had automated a lot of things inside our environment, but unfortunately not everything. And this was especially true as you dove deeper and deeper into the infrastructure and started touching things that had been running and supporting the environment for many years. So with this project, it was important that we determined how to automate everything so that we could have very limited human involvement when we needed to bootstrap new environments. So one of the first challenges that we were going to face in this was simply around broad cross-team communication and coordination. A few years ago, New Relic significantly reorganized the way that its engineering teams worked. So this was done to help break down organization blockers and also to provide teams with much deeper autonomy and code ownership. In essence, each small engineering team had become its own small functional unit. This did wonders for velocity in day-to-day operations, but by design, it made large cross-organization projects trickier. This multi-region effort we were about to embark on would be one of the first times that we would test how well we could take a strategic project that was prioritized up at the organizational level and coordinate across a broad range of semi-independent teams while still giving them enough room to self-prioritize specific tasks at a more tactical level. So at the start of this project, New Relic was over 10 years old and had the technical debt to match our age. Our US region had been organically grown over the years, and because of this, it had a wide range of technologies and processes that were required to manage it. Many of these processes overlapped, and it was often unclear to teams what the current best practices were. Similar problems to these are probably shared by many of us here. So in New Relic, we asked ourselves, where should we start with this project? One of the earliest things we decided to do was create a very small team of engineers. It was made up of 5 people who, when taken together, had a very broad range of technical skills, but still deep knowledge of the New Relic platform itself. Like the tugboat above, this team would be purpose-built for the project at hand. This would allow them to be agile and stay focused on the specific goals of this project without being distracted by many of the other priorities within the company. In addition to delivering technical solutions, this team was expected to be the primary source of communication and coordination that would be required to ensure that the broader organization was well-informed and set up for success. So after setting up the team, we then proceeded to do a survey of all the technology and tooling that we were already using. As you may notice, this included a great deal of overlapping solutions. Most of these tools were not consistently used across the company, and even the way with which individual tools were used depended a great deal on when the team had first adopted them. It was obvious that we needed to limit this down to a well-defined set of choices if we're going to have any hope of pulling this project off. After some initial discussions, we had a pretty good idea of what we wanted to scope the technology choices down to. But we still needed to prove that our understanding of the requirements was solid, and that these technology choices would actually work as expected for every use case that we had. To remain as agile as possible, while managing the large scope of this effort, we decided to design the whole project around a small iterative process, where we identified the next major step, designed a solution, and then implemented it. This helped to ensure that we discovered unknowns and potential blockers as early in the process as we could, when it was still very easy to adjust for them. In the early stages of this project, we created a very lightweight centralized web portal that we could use for communication and coordination efforts across the broader organization. Then we spent some time defining a core set of results that we wanted to achieve while also identifying the technologies that would enable each of those to work. We knew right away that we wanted to ensure that we were building interfaces at every single layer of the process. This was crucial if we were going to make the process pluggable and to ensure that we could migrate it to new data centers, cloud providers, and back-end technologies in the future. Docker helped us a lot with this by ensuring that we had a standard software packaging format, the Docker image, and a single deployment interface, the Docker API, for our internal platform to leverage. Docker also gave us solid visibility into container statistics and events that we could then ship off to other locations, including our own New Relic products. To help facilitate this, we knew that everything would need to be defined in code. To build the infrastructure from scratch, we had to ensure that there were not a bunch of manual steps scattered throughout the process. We wanted to be confident that a new region could be bootstrapped with a minimal number of steps. So to accomplish this, we leveraged Terraform and CoreOS. Terraform is used to manage API-based operations on most parts of the infrastructure. Using Terraform, we can easily create, modify, and delete most resources, including things like DNS entries, compute nodes, object store buckets, and much more. So CoreOS, on the other hand, provides a tool called Ignition, which can be used to define exactly how the operating system should be set up on its first boot. Ignition basically provides a well-defined, one-time configuration management run during the host's initial boot. Within our Terraform code repository, each suite of New Relic services has its own configuration, which programmatically creates all the required resources for that service. This workflow is then managed by a Jenkins job, which can be used to ensure that the code changes interact as expected with the real infrastructure. Whenever a pull request against this repository is made, Jenkins performs a Terraform dry run and then injects the results of that dry run into the PR comments so that it's very clear what running the submitted code changes will do if they're actually applied for real. When the pull request is then merged into master, a new plan is run, and if that plan is approved, then those changes will actually get applied to the live environments. So to support Ignition, the CoreOS tool that is used to bootstrap the host configuration during the first boot, we decided that each compute node would have a single role assigned to it. This is based on what purpose that node has in our environment. Every node with the same role would be set up the same way, and the role would be defined via a very simple tag on that compute node. So despite the fact that Ignition expects a JSON file, we actually store all of our configuration for each role in multiple YAML files, because YAML is simply more human-readable than JSON. Then during provisioning, these individual files are deep merged into one large YAML configuration, and then this YAML file is finally converted into the JSON that Ignition requires when running. These YAML configuration files we use for the node roles are actually templates that are processed by a Go application. And this allows us to easily inject things like secrets and environment variables into the configuration from Vault and other sources without needing to store sensitive or variable data inside our repositories. The next thing that we wanted to actively move towards was an immutable infrastructure, a model that encouraged reprovisioning hosts regularly over performing ongoing configuration management. Since every hardware-owning team in New Relic was responsible for its own operational tasks, it was important that the system we built was trustworthy and that teams knew that they could rely on it. Since in most cases, trust comes from experience, we wanted to be sure that we built a system that could safely and quickly reprovision nodes so that teams could do this frequently and reliably. So as we just discussed, for this, we leveraged CoreOS's Ignition and Vault so that we could tag a node with a role, and then Ignition would set up the new systems according to the defined configuration for that role, while also then leveraging Vault for any secrets and service endpoints that the service might need to write into configuration files. Containerization was incredibly important to the project. CoreOS has no package manager, and it exclusively leverages containers for running software. Now, granted, we could have picked a much more flexible Linux distribution, but this choice actually helped enforce container-first habits that we really were trying to encourage with teams. And most teams had already actually made the conversion to containers. In addition to providing the Docker image and Docker API interfaces, using Docker also meant that all the build steps for the software we deployed could be well encapsulated inside the Docker file and relied on to be immutable outside of planned deployments to production. We use containers for absolutely everything. This means that even low-level software that some of our core infrastructure teams rely on, things that cannot easily be run in our own internal container platform, are still containerized. In most of these cases, we leverage things like systemd and Docker so that the general functionality and experience of running software is as similar as reasonably possible. However, the majority of our software is deployed into our highly scalable internal platform, which then schedules and orchestrates all of the services that New Relic needs to run so that we can deliver our product to the customers. Once the core software was deployable on a host, either natively via, say, systemd or via our broader container platform, then we also needed to ensure that everything in the environment was discoverable. We standardized naming for most entity types that might be represented by things like DNS names. And since at some level, Vault is basically just a security-focused key value store, we actually decided to leverage Vault to bootstrap the service dependency, or the discovery of service dependency endpoints and authentication information. This meant that services did not need to inherently know anything about region-specific URLs or tokens that they might need to connect to their dependencies. Instead, they would get fed all of this information during deployment. To accomplish this, we developed an internal service called Biosecurity, which is leveraged by Grand Central, which is our unified deployment tool. Using these two tools, it's now possible for all of our services simply to define what URLs and authentication information they need at startup, and the correct information for that environment will get injected into the service during deployments. During this whole process, we actively looked for places we could replace older tooling, things like Nagios and Cacti, and with our own New Relic solutions. This was to greatly improve our visibility into the state of our environments. Tools like containerized infrastructure agents, synthetics monitoring, insights dashboards, and alerting were all invaluable in consolidating how we monitored and where we had to look for the data that we needed to make informed decisions about the environment. Now, although immutability is an important goal, we also still wanted to make sure that we recognized that this was going to take some time for teams to adjust to this new paradigm, and that we still needed to also be properly prepared for anything that the real world might throw at us. For example, if there was a new security exploit, Terraform would allow us to easily reprovision hosts with a new CoreOS update. However, sometimes that simply may not be practical or reasonable depending on what the issue is and how many hosts it impacts. Because of this, we developed an Ansible container that was ignition aware and could roll out file-based changes to a fleet of hosts very easily. This meant that we could if there was something like a simple SSH configuration that had a security issue, we could fix it in Ignition so that new hosts would get the correct file, but we'd still be able to reliably push that exact same change that we checked into ignition out to hundreds of live servers using this Ansible container without being forced to reprovision them all for such a small, well-defined change. The ignition-aware Ansible container that we developed for this purpose is also designed to be run via a Jenkins workflow. Jenkins can run Ansible in check mode, and then it can highlight all of the alterations that would be made if this check was run for real. Once the changes have been confirmed, then the job can be kicked off, and the fixes can be applied to as many systems in the fleet as is required. By deciding to stand up a small and agile team that could focus exclusively on the goals of this project, we were able to quickly identify where we should spend most of the time to significantly improve the day-to-day solution for engineers while also meeting the overall business goals. And even more importantly, it enabled us to deliver a faster and more reliable product to our customers. By handling the project the way that we did, in just under a year, we were able to take our single region in the United States and add another fully functional production region in Europe. But it didn't end there. While developing this region, we completely built and tore it down 4 times. And then a few months later, we used the exact same toolchain that we had used to stand up the EU region to run our official disaster recovery event in the Southwest United States. In previous years, our DR events had been very, very laborious for engineering. This year, we lowered the engineering hours required by a magnitude of 10, and we cut the budget by 25%. In the future, we should still be able to trim a lot as we improve the process and we still iron out more of the wrinkles. I hope that this talk has given you some insight into how New Relic approached solving one of its own modernization efforts, and gives you some encouragement that you can do the same things within your own organizations. To paraphrase Margaret Mead, never doubt that a small team of thoughtful, committed people can change the world. Indeed, it's the only thing that ever has. Like the tugboats in the video above, as long as the organization is open to change, then even small teams, properly aligned and leveraged, can move the whole organization in a new, forward-looking direction. Thank you very much, and enjoy the rest of your day.